This is AQA GCSE Chemistry. It's a dual award and triple award topic. Chemical calculations. In part 2, we're going to revisit balancing equations and we're going to start to do some more complex molar calculations. So I'm going to jump straight in with the objectives, and I'm going to recommend that you try each activity, pausing the video as you go. So in this, we're going to look at balanced symbol equations, see what that tells us, and then use those balanced symbol equations to actually calculate masses of reactants and products when provided with information. Now, there is an earlier video where these equations have already been covered back in chapter 2. But it's always a good opportunity to double check that you're happy with the skills. So pause and take a look at the examples. We have the one here, balancing hydrogen and chlorine reacting to make HCl. We have another one here where we're combusting butane. And there are 4 sets of 5 equations to balance for you to try to see how you do. Like I say, pause as you go, and then you'll get to see how confident you are with this particular skill. It's a very important skill. So here are the first 5. And I'm not going to go through the explanation of this. That can be found in the earlier video, but I will show you the answers so you can check. So we need the 3 and the 3 in the first one. On the second one, we need 2LIF. On the next one, we need 3O2 and 2P2O3. On to the next one, we've got 2RBNO3 and 2RBF. And finally, we have 2 silver nitrate and 2 silver. 5 more for you to have a go at. And on this one, it's the bromine and fluorine that aren't balanced. We need 2Br2 and 2F2 to balance out the equation. On the next one, I've got 2 CNs here, so I need 2 HCN to balance it. The rest of it is done. On to the next one, we have got 3 CS and 3 CSF. The next one is already balanced. And finally, the Haber process equation on this set, we need 3H2 and 2NH3. 5 more to look at. And it's 2NAF and 2NABR. On the next one, 2HCl and 2H2O. On to the next one, going into slightly bigger numbers, we're balancing the aluminiums. I need 2AlBr3, which means 6Br, which means 3K2SO4. And then a combustion equation, I need 2H2O and 2O2. And finally, on this set, 2Na3PO3, 6Na, and 3CaCl2. 5 more to finish off. And it's 2K and 2KCl, 3HCl and 1.5H2. Now you could multiply all of these up by 2 and have 2, 6, 3, 2, but half molar numbers are absolutely fine. The next one, 3F2 and 2NF3, and 2Li2Se and 2Li2O, and finally we have got 2NH3 to balance this equation. Now, the purpose of these is that when you've got a balanced equation, you can start to do calculations with it. And I'm going to go through a worked example of the sort of calculation that you are then going to have a chance to try. So we've got a question here. If 48 grams of carbon were fully reacted with oxygen, what mass of oxygen would it react with? And the steps that you need to get comfortable with, there are different ways of doing it, but I'm going to recommend you get to grips with learning this table, drawing it, and filling it in. So for step 1, it's a matter of having this table. The mass, the relative formula mass, or molecular mass, or atomic mass, the number of moles, and the mole ratio. And then you are going to add in 2 species at the top. One that you've been given the mass of, and one that you want the mass of. And that will be the same in any example of question like this that we do. So in this case, it's the C and the O2. At that point, I can now start to fill in the table. So I'm going to start by saying that if I've got 48 grams of calcium carbonate, 48 grams of, it's actually carbon, so apologies for the typo there, but I put that one in. But then I can put in my relative masses. I've got O2, which is 16 times 2 is 32, and I've got carbon, which has a mass number of 12. Now, because I have got the mass and the relative formula mass, I can work out the number of moles of carbon. I can then use my equation. My equation tells me that my mole ratio of carbon to oxygen is 2 to 1. 2 moles of carbon react with 1 mole of oxygen. So I've got my mole ratio here. And if 2 moles react with 1 mole, then 4 moles will react with 2 moles. So I can start to fill the table back in the other way. And because I've now got my number of moles and I've got my relative formula mass, I can multiply those together to get my mass of 64 grams. My final step is to make sure that that is written outside the table. So let's look at some examples, try each of these and then follow the review through. So, in the first instance, we are going to draw out the table and we're going to put in the species I want the mass of and the species I have the mass of. I can now put my mass of magnesium oxide in. I can find my relative formula mass of MgO and my relative atomic mass of magnesium, 40 and 24. Because I've got the 4 and the 40, I can work out that I've got 0.1 moles of MgO. I now look at the mole ratio. 2 moles of magnesium make 2 moles of magnesium oxide. So my ratio is 2 to 2. If my ratio is 2 to 2, my ratio is 0.1 to 0.1. I've now got 0.1 moles and a mass number of 24. I can multiply those together and I've got 2.4 grams of magnesium. Next example for you to try. So I draw out my table. I've got the mass of calcium oxide that I want and the mass of calcium carbonate that I have. So they're the two species that I put in. I'm told that I've got 25 grams of calcium carbonate. I work out the relative formula masses, 100 and 56. And because I've got an M and an MR, I can work out my number of moles. 25 over 100 is 0.25. The equation is a 1 to 1 mole ratio. So 1 mole makes 1 mole, which means 0.25 moles makes 0.25 moles. I now have a moles and a relative molecular mass. I multiply those together and I get my mass of 14 grams, which I've written outside the table. Next example. And in this case, we are interested in the Fe2O3 and the Fe, so they go into my table. The rest of the table is identical. I'm told that I've got 16, actually kilograms, but it scales up. So I'm just going to put the 16 in. 16, and I've got my relative molecular masses of 160, and actually relative atomic mass of 56. 16 over 160 gives me 0.1 moles, and my mole ratio here is 1 to 2. So 1 to 2 ratio means 0.1 moles would make 0.2 moles. I've now got my moles and my relative atomic mass, multiply those together, and it gives me 11.2. Now, if that was 16 grams, it would be 11.2 grams. It was 16 kilograms, so it comes out as 11.2 kilograms. And if I did it as 16 tons, it would be 11.2 tons. Next example. So in this case, we're interested in sulfuric acid and sulfur dioxide. I put those two into my table. I'm told that we've got 320 of the sulfur dioxide. I put my relative molecular masses in, 64 and 98. Because I've got an M and an MR, I can work out my N, which is 5, and my mole ratio here is 2 to 2. So if 2 moles makes 2 moles, 5 moles makes 5 moles. I then multiply my N and MR together to give me a value of 490. Because we started in kilograms, we end in kilograms, 490 kilograms. Next example. And we're interested in the glucose and the ethanol, so I put those in. I'm told that I've got 4.5 grams of ethanol. I find the relative molecular masses, they're 46 and 180. Because I've got an M and an MR, I can work out my number of moles, which is 0.025. My mole ratio here is 1 mole of glucose to 2 moles of carbon dioxide. So 0.025 to 0.05. I can now multiply my 46 and 0.05 together, and it gives me a mass of 2.3 grams. I'm hoping you can see there's a systematic route through these questions. On to the next example. And in this case, we're interested in the aluminium and the iron oxide. I'm told that I've got 8 grams of iron oxide. I work out my relative molecular masses, 160, relative atomic mass of 27 there. Because I've got the 8 and the 160, I can work out that I've got 0.05 moles of Fe2O3, and my mole ratio here is 1 to 2. 1 Fe2O3 reacts with 2 Al. That means on a 1 to 2 ratio that I've got 0.1 moles of aluminium. Because I've now got my N and my Ar, I multiply those together and I get 2.7 grams. Move on to the next example now. And we're interested in ammonia and hydrogen. So let's put those two into the table. 12 grams of hydrogen. Mr is 2 for the hydrogen, 17 for the ammonia. 12 over 2 gives me 6 moles, and I've got a mole ratio of 3 to 2. So on a ratio of 3 to 2, it becomes 6 to 4. I've now got my 4 and my 17, multiply those together, and I get 68 grams of ammonia. And moving on to the final question, we've got copper and sulfur that we are interested in. I put those in. So it's relative atomic masses we're going to use in a moment. 8 grams of copper. Relative atomic mass is 63.5 and 32 respectively. That means I can work out my number of moles. M over Ar comes to 0.126. My mole ratio is 2 to 1 because 2 moles of copper react with 1 mole of sulfur. That means that I can use my 2 to 1 ratio to see that I have 0.063 moles of sulfur, and because I've got my 0.063 and my 32, I can multiply those two together and I get 2.02 grams of sulfur were needed. A really common calculation, a really important calculation to get your head around. It's good to practice these repeatedly to make sure you're confident with that process. That takes us to the end of this video. Thank you for listening and goodbye.